Welcome to the Chemistry for Dummies program. Today, we will be talking about changes of state and all the factors which affect them. Our group will give you an in-depth presentation as to how equilibriums function and are affected by outside forces. It might sound somewhat complicated, but once we show you the simplified version of everything, you'll see that it's quite simple to understand. Well, now, me and my team, we're going to show you a couple parts of this section. And like I said, once you get through it, it's going to be really easy to understand, although it may seem somewhat really difficult and complicated in the book. Let's get started.
So what is equilibrium? By definition, equilibrium is a dynamic condition in which two opposing changes occur at equal rates in a closed system. An easy way to remember this is equal equilibrium, which is a root word, so you'll always remember, like this. Think about a seesaw. If two individuals having almost identical weights sit on the opposite sides of the seesaw and also make sure that the distances from the fulcrum are the same, then the seesaw would not be tilted. This would be considered stationary and straight, and it would cause, and this would be the point of equilibrium or balance of the seesaw. If an additional person sat on either side of the seesaw, then the state of equilibrium would be broken or disturbed. Next, a phase is any part of a system that has uniform composition and properties. Some examples include liquid phase, which is when the molecules are in a liquid state, vapor phase, which is when the molecules behave like typical gas molecules, etc. Condensation, which is the process when a gas changes to a liquid, is a product as the molecules leave the liquid phase to join the vapor phase and then gradually move down to the liquid surface and condense and re-enter the liquid phase. Equilibrium can also be expressed as an equation called equilibrium equation. Here's an example. So whenever a liquid changes to a vapor, it is expressed as the following equation. Whenever the vapor condenses, it is expressed as the following equation. And the liquid vapor equilibrium can be represented by the following equation. Notice the similarities between all three. The last equation represented has double yield, meaning that the equation can go in either direction, representing equilibrium, hence the term equilibrium equation. And that's it.
Vapor molecules in an equilibrium pressure, they exert a force proportional to the vapor concentration. The pressure exerted by a vapor is called equilibrium vapor pressure. The increase in equilibrium vapor pressure with increased temperature can be explained in terms of kinetic molecular theory for all liquid and gaseous states. Because all liquids have characteristic forces of attraction between their particles, and also every liquid, they each have a specific vapor pressure at a given temperature.
Alright, so there are three important things that you have to remember about my section. The first one is that vapor pressure is increased when temperature is increased. The second is that gas inside a container is known as vapor pressure. And the third is that all substances have different vapor pressures at different temperatures.
Bueno, like here we have what we call equilibrium equation. An equilibrium equation is when you have two equilibriums of opposing forces which are in a constant cycle and they continue the equilibrium. Here we're going to learn about una cosa que se llama Le Chatelier's principle. Le Chatelier's principle was this idea which stated that whenever a stress is exerted on an equilibrium, you're going to get a new equilibrium, pero it's going to have like minimal stress. It's not going to have as much stress as it did before. And then it's going to stay like that until a new stress comes up, and then it'll eventually change to minimize that stress. Okay, entonces mira, here we have factors that affect the equilibrium. We have two majors, que nada más dos, no más que dos. Entonces, the first one we have temperature. When you add temperature to an equilibrium, there's a chance that it's going to add more energy. For example, if you look at this one right here, if you add temperature to this, you're going to convert the liquid into vapor. You know, like when it rains, water falls, it gets hot, it goes back up, the sky, yeah, that. When you reduce the temperature and it gets cold, for example, here in the vapor, it'll revert back to its prior state, to the liquid. So like that, it loses energy and it gets, back to the water. So think about it, as the rain, you evaporate, rain goes up, and when it gets cold up in there in the sky has daylight, then it comes back down as water. Alright? And that keeps going in a little cycle, un ciclo, como la estación del año. It keeps going. Another one we have, a major one, is concentration. Concentration, it can affect an equilibrium in a really big way. For example, mira, let's say you increase the volume of an equilibrium, the concentration is going to decrease because now the molecules are going to be in a bigger area. So está regado. So there's going to be such a bigger area, eventually to establish a new equilibrium, you're going to have a movement from energy from one side of the equilibrium to the other. So once an equilibrium is established and the stress is minimized, you're going to have a big area and a small area with the same amount of molecules until the stress is applied. Bueno, mira, aquí te dejo. That's about everything. And to start off our presentation, I introduce you my one, my only, my most special best friend, Ali Goya.
Hi. Today, the section I will be discussing with you is equilibrium and its shift when temperature is applied. As you see here, when temperature is applied, when heat is applied to an element, that element will cross over to the other side and raise these elements, therefore causing a shift in equilibrium. In equilibrium, both the energies are supposed to be the same, and when you shift one because of heat, they will be unequal, which is normal. Therefore, showing that there is a shift in equilibrium when heat is applied.
In this section, we'll be talking about liquids and their characteristic forces. All liquids have characteristic forces of attraction between their particles. Every liquid has a specific equilibrium, vapor pressure at a given temperature. Bottled liquids are liquids that evaporate readily. It is important not to confuse the equilibrium vapor pressure of a liquid with the pressure of a liquid of a vapor not in equilibrium with its corresponding liquid. Boiling is the conversion of a liquid to a vapor within the liquid as well as its surface. It occurs when the equilibrium vapor pressure of a liquid equals the atmospheric pressure.